Hello, I'm Hubert and welcome to Decodable Demos, where we demonstrate all things related to streaming. Today's demo will show how Decodable works with Confluent by enriching clickstream data coming from Confluent Cloud. As you see, we're in Decodable UI right now, and we have a lot of connectors running right now. First, we need to set up the Confluent Cloud side, so we'll jump over there really quickly to do that. Go to your environment and the cluster that you've already created. And we're going to create a connector. So we're going to create a data gen connector, which generates mock data. And we're going to use this topic that we've already created, clickstream Avro. So we're going to be using consuming Avro data from Confluent Cloud. I already have a key, so I'm going to use that right now. Let me just grab that over here. You can generate your own over here if you'd like, but I don't like to. I want to reuse some of my keys, so. Here we're going to pick clickstream. There's a set of data sets you can choose from, and we're going to choose Avro as the data format. We're just going to call it clickstream. Great, connector created. As this is being provisioned, we can go ahead and create our connection to Confluent Cloud. First thing we do is click this button over here, new connection, and navigate through all the connectors we have. There are two options that involve Kafka. We want to use the Confluent Cloud one because we do pull in more metadata from Confluent Cloud. Okay. Specifically join that connector. So we want to grab the connector ID. Where you find that is over here, cluster settings, cluster ID, copy that, paste that here. We also want the cluster API endpoint. This is a bit different than other clients that connect with Kafka. Usually you provide the Bootstrap server, but since we are working directly with Confluent Cloud, talking at an API layer to get more metadata from Confluent Cloud, we're going to talk to the REST endpoint. Okay, I have my cluster API key here already. I'm going to reuse the one that I created earlier. And the value format is going to be Avro. As you see, since we're using the API endpoint to connect to Confluent Cloud, it's able to pull in more metadata. This is the list of topics that we can choose from, and we are writing our clickstream data into this topic right here. Okay, I should not have an existing stream. In Decodable, streams are very much like tables. We have different types of streams. In this case, we're creating an append stream of we're appending clickstream data into that stream. It's like a table. So we're going to name this clickstream Avro. The same name we're giving the topic that we're consuming from in Confluent Cloud. Okay, we are going to create a new schema, but we're going to use schema registry to get this information. As you can see, it's asking us for a bit more information. It wants the schema registry endpoints so that Decodable can talk to schema registry directly. Where we find that is over here. Go to the close this here. There should be a schema registry endpoint here. This is running already, it looks like. Actually, you want to go to the environment. So you go to the default environment, since we are in the default environment, and over here you'll find the schema registry information. Right? Here's the endpoint, so you want to copy that. Go back to decodable and paste that value in here. And now you want to get the API keys specifically for schema registry. So you can click in here, view the existing API keys and secrets. I already have mine, so I'm just gonna copy mine and paste it into the decodable configuration for schema registry. Great, and we're gonna name this connection clickstream avro source. Let's create this connection and start it. As you can see down here, you see some metrics coming in already. It's not a fully starting, but we are getting data. There it is. It's running now. Click here. We should have some data coming in into our stream, our append stream, clickstream avro. Great. Now we're getting data from Confluent Cloud directly. Now we want to enrich this data with some information. In particular, we are going to connect to a Postgres database with user information, and we're going to use that user information to enrich the clickstream data coming from Confluent Cloud. So if we click a new connection, we're going to create a Postgres CDC source. So we are going to join existing users, or in this case customers. If you think of like an e-commerce site, and you have users clicking on the site and going to pages and looking at specific images, we could actually capture existing users that are registered with our e-commerce site to see their activity, provide them promotions and coupons and so on, right? So that's what we're going to do here. We're going to grab our existing users or customers from Postgres and see if we can get them some coupons for our database. I'm using dbeaver to show my information in Postgres. So let me just refresh my connection in here. And we have a table here already populated with users. So just refresh this. Okay, so we're going to use this information to enrich our clickstream data. So our customers. Make sure it is customers, yes. And excuse me, we're going to create a stream here. We're going to create, I guess, like a new schema. If you go back to our dbeaver and look at the properties of this table, we can just copy this over using, well, I guess, hand typing it. This is an integer. So by specifying that this is a primary key, this will create a stream that is called a change stream, meaning it's going to capture change data capture data or CDC data from Postgres and materialize that data as like a table view in decodable. Okay. So this is going to create a change stream, and change streams are typically associated with CDC data, in this case Postgres. Great, so this is going to be our customers source. There's already one called that, so Postgres source. Looks like this name is already taken, customers Postgres. Okay, great, let's start that. Great, so this is running already. You can see some data coming in. Click over here, you'll see the 7 users that we saw in Postgres over here. Okay, notice the format that there's a key here associated with the user ID, and then the format over here is the Debezium format. We are using a Debezium connector to grab that data from Postgres, and since this is the initial snapshot, there's no before version of this, but there is an after version, and we are reading this, and this is the timestamp we first read it. So if I were to go back into our database and go into my own record here and change my phone number to like that and save that, you'll see another record come in here with the ID of 3. We just play this again, and there's that record down here. You notice that there is now a before and after record. This is the before, this is the after. So if you're trying to create a materialized view or a view of latest versions of the user, you always want to grab the after context here, where I changed the number from 5555 to all 6s here. Okay, so this is what a Debezium format looks like. This is the operation, it's U for update, and this is the timestamp at which it occurred. Okay, so if we were to create a materialized view for this, and for instance, if I wanted to join this data with something else, it's not going to grab any of the older versions of it. It's going to only grab the latest version for that particular user. Since I changed myself, I will get the latest phone number for Hubert Delay. So now we want to actually join this data with the clickstream data. So we have clickstream Avro, and we have Postgres users. So if we click on Avro again and click these 3 dots here, we could create a pipeline. A pipeline is just simply a SQL statement that can enrich and join and transform your data in real time using streaming technology. Okay, so I already have the SQL that I would like to use. So I copy that, paste that into here. Okay. A few things that we're doing in here, we're escaping the time because that is a reserved term in SQL or in Flink SQL. We are adding a new column called underscore time, and we're going to give it the current timestamp for that. And also we're adding another column to this where the data is where we're taking the data out of we're splitting it into like terms by space, and we're getting this term, which is the second term, is 0 based, which provides us the URL to where the user is clicking to. Okay, all that information. There's more information in this request, so that we're only going to grab one to split it out into the URL column. Okay. Here is the join itself. It's doing an inner join, so that's important, meaning it'll only grab records or enrich records, clickstream records, for which there is a corresponding customer. Okay, so you will not see records come through where there are no customers for. So that's what this inner join for. If you wanted to do that, you could change this to a left join and get all click streams, and you'll get just null for the customer information. But since we don't want to do that, we want to only provide coupons and benefits for our existing customers. We want to do an inner join here. And to test this out, we can click this button down here, run preview. Sorry, I misnamed the name of the columns, or I'm sorry, the table. So if I go to click Avro, it's actually click Avro, clickstream Avro, and it is customers. Right. Customers. This is what I get for copy pasting. Let's copy that, paste that there. Great, run this preview. And since this is reading from the end of the stream, there's no additional changes coming through, but that'll change. So if I change this back to 5s and save that, you'll see one record come through. It's all Hubert's, and you'll see that it's being changed back to all 5s down here. Okay. Notice the request. There's a lot more information in it, and we pulled that out into the URL, but the link that they were clicking into. Okay. We also added a timestamp. Okay. So let's go next. The table that I wanted to write this into, if you go back really quickly, this is going to insert into a stream called customer last URL visit. This stream does not exist yet, and Decodable notices that and offers to create a stream for you. Notice that there's a primary key to it. That means that the output of this is going to be a change stream. Okay. Actually, this already exists from a previous demo. I'm going to just reuse that stream and that inferred stream. Okay. We're going to name this pipeline click customer enrich pipeline. And let's start this, but let's start it from the beginning, okay? Because we want to consume all the data that's been already consumed. That includes the snapshots and any previous changes that I made, in particular to my record in Postgres. So let's start that. Great. Now it's running. Notice that this is the number of records that came in. It looks like it consumed a lot more than some previous records there. And total records 324. These are clickstream data, so you're going to have a lot of records coming in. The output metrics are going to be the records that are involved we were able to match in the inner join. Okay. One thing I want to point out here is that our lineage graph, or not graph, but like forward and backward buttons, just like our browser buttons. You can click here and notice that it parsed the SQL and identified the two tables that we were joining. So click stream Avro and customers PG. And close that. This is the output stream we're writing the data into. So click there. You'll see all of the data for every user that we have in here. before and after values. So if you click in here, you'll see that we've added records. We've enriched the BCM format with clickstream information. Okay. Now we want to put this into a sink. Okay, we're going to actually write this back into Postgres with the same information that we have, but we're going to materialize this information into a specific table, right? The idea here is that this Postgres could actually be a database a microservice is using, so that in real time this microservice can provide coupons to our existing users or customers. Our table name is in here. We're going to use customers last URL visit. Okay, we've already created it in here. Username, first name, phone, IP. We'll match that. Here it is. That schema precisely in here. Okay, so click in here. We're going to use oh yes, this guy. It already exists. So it has all the same fields: IP, remote user, time, request, URL status, and so on. Okay. So we'll click there, and let's call this click customer PG sync. Let's create this connection. Relation last URL does not exist. Go back in here. Let's double check our work here. Customer last URL visit. Create a sync. That table name, customer last URL visit. Great. One thing I want to do here is that is to change the schema a little bit. Since the timestamp in Postgres is a bit different than the timestamp that we have in here, we only want this kind of timestamp, okay? And since we can cast that down to this type of timestamp, this should be okay to do, okay? So let's continue on. Create the connection, the sync. And the table name is great. Click customers Postgres sync, and let's start that. So when we go back to our dbeaver and look at the data in here, what we should see are updates to all of these records. Let me just truncate this this table here. before this gets running. Oops. Okay, so let's refresh this. And let's have it refresh every 5 seconds so that we are seeing new records come in. Just waiting for this to start. If we go back to our SQL, this is a different timestamp than what is in the database, so we want to cast it. Down. So let's save that version. Let's stop this one and restart it from the beginning. And there we are. This is still updating every 5 seconds. What pages they're looking at, and then maybe offer up some coupons for them to get them to purchase. Okay. Thanks a lot. Appreciate your time. If you have any questions, definitely reach out to us at support@decodable.co. Also join us at our Decodable community channel on Slack.